When we slide or attempt to slide an object over a surface, we create two reaction forces. The first reaction force is the normal reaction force Rn that opposes the force pushing the object and the surface together. The normal reaction force is always perpendicular to the surface on which the object rests. The second reaction force is the friction force, which opposes the sliding force. The friction force is always parallel to the surface on which the object rests or slides. To the right, we have an object sliding on a surface with an applied force, Fa, parallel to the surface. Rn, the normal reaction force, is created by the weight of the object, and like the weight, it is perpendicular to the surface. The friction force, Ff, is created by the applied force, Fa, and since Fa is parallel to the surface, so is the friction force, Ff. Even when the sliding force is not applied parallel to the surface, Rn, the normal reaction force, is still perpendicular to the plane, and Ff is still parallel to the plane. In this case, Ff is parallel to the horizontal component of the applied force, which is Fax. We can solve for the resultant of the two reaction forces, Rn and Ff, by drawing a vector diagram. In a vector diagram, we connect the forces head to tail. A line drawn from the origin to the end of the last force indicates the direction and magnitude of the resultant force. It should be noted that since Rn and Ff act at right angles to each other, their resultant, Rr, is the hypotenuse of a right-angled triangle. So here we have a space drawing showing the four forces acting on an object when we attempt to slide it. The applied force, parallel to the applied force, is the friction force, which is parallel to the surface. And we have the weight of the object and its reaction force, Rn, perpendicular to the object. For the two reaction forces, Rn and Ff, if we draw a vector diagram, we attach the forces head to tail. Rn, Ff is at right angles, and the resultant reaction force of Rn in Ff, which is Rr, is shown here. In the vector diagram, for the resultant Rr of the two reaction forces Rn and Ff, the angle between the resultant reaction force Rr and the normal reaction force Rn is called the friction angle. The friction angle is a theoretical angle and is present any time we create the reaction forces Rn and Ff by trying to slide an object across a surface. The friction angle is not the angle of inclination. In the diagram to the right, we see we have a force applied at an angle to the horizontal. That angle is the angle of inclination. We also have the friction angle, which is the angle between the reaction force Rn and the resultant reaction force Rr, of the two reaction forces FF and RN. The friction angle is present when sliding an object even when the angle of inclination is 0. In the diagram on the right, we see we are applying our force to slide an object parallel to the surface, so there is no angle of inclination, but we still have a friction angle because we are still generating the reaction forces Rn and FF. Example 1. A force of 100 newtons is applied to slide an object of 981 newtons across a horizontal surface at constant velocity with the force applied parallel to the surface. What is the friction angle? So we have a force of 100 newtons. It's applied to slide an object of 981 newtons across a horizontal surface at constant velocity with the force applied parallel to the surface. We want to know what the friction angle is. Step 1, we're going to find the normal reaction force Rn. The normal reaction force Rn will equal the weight, which is 981 newtons. Step 2, we're going to find the friction force. Since the object is sliding at constant velocity, then the friction force FF equals the applied force FA. So the friction force is going to equal 100 newtons. Step 3, we're going to draw a space diagram. A space diagram shows all the forces acting on the object from the central point, which is going to be the center of the object. Step 4, we're going to draw a vector diagram showing the two reaction forces Rn and FF. So we are going to draw them head to tail. So Rn acts vertically and it has a magnitude of 981 newtons, and FF acts at right angles to Rn with a magnitude of 100 newtons. Connecting a line from the origin to the end of the last vector FF gives us the direction and magnitude of the resultant reaction force RR. The angle between RR and Rn is the friction angle. Step 5, finding the friction angle. The friction angle is the angle between RR and Rn. Now we know the tangent of an angle equals the side opposite the angle divided by the side adjacent to the angle. In this case, the tangent of the friction angle will equal FF divided by Rn. So, tangent of the friction angle equals 100 newtons divided by 981 newtons. The tangent of the friction angle is 0.1019. Finding the friction angle from the tangent, we get 5.82 degrees. So, the tangent of an angle equals the side opposite divided by the side adjacent. From the vector diagram showing the friction angle, we can see the tangent of the friction angle equals the friction force FF divided by the normal reaction force Rn. But the general friction formula tells us the coefficient of friction equals FF divided by Rn. Since both the coefficient of friction and the tangent of the friction angle equals FF divided by Rn, then we can say the tangent of the friction angle equals the coefficient of friction. So if we know the coefficient of friction, we can find the friction angle. And if we know the friction angle, we can find the coefficient of friction. Example 2. The coefficient of static friction between an object and a surface is 0.28. What is the friction angle? So the coefficient of static friction between an object and a surface is 0.28, and we want to know what the friction angle is. Well, the tangent of the friction angle equals the coefficient of friction. Tangent of the friction angle equals 0.28. Finding the angle from the tangent, we get a friction angle of 15.6 degrees. Example 3. The friction angle for an object sliding across a surface at constant velocity is 21 degrees. What is the coefficient of kinetic friction? So the friction angle for an object sliding across a surface at constant velocity is 21 degrees. We want to know what the coefficient of kinetic friction is. Coefficient of sliding friction or kinetic friction equals the tangent of the friction angle. So we can say UK, the coefficient of kinetic friction, equals the tan of the friction angle. Coefficient of kinetic friction equals the tan of 21 degrees. The coefficient of kinetic friction is 0.38. Now we are going to look at two important relationships involving the friction angle. The first relationship is the one between the friction angle and the angle of inclination. Now we've stated that the friction angle and the angle of inclination are not the same angle. But there is one case where they both have the same value. The angle of inclination, which will require the least force to start an object moving or keep it moving, has the same value as the friction angle. So if we know or can find the coefficient of friction, or if we can find the friction angle, because the tangent of the friction angle equals the coefficient of friction, this is also the angle of inclination that will require the least applied force to start or keep an object sliding at constant velocity. Example 4. An object has a mass of 100 kilograms. If it is to be pulled along a horizontal surface at constant velocity, what is the angle of inclination that will require the least force to slide the object if the coefficient of kinetic friction between the object and the surface is 0.33? So an object has a mass of 100 kilograms. If it is to be pulled along a horizontal surface at constant velocity, what is the angle of inclination that will require the least force if the coefficient of kinetic friction is 0.33? Well, we know the angle of inclination that will require the least force has the same value as the friction angle. And we know the tangent of the friction angle equals the coefficient of friction. So we have the coefficient of friction, which is 0.33. So we can say the tan of the friction angle equals 0.33. Therefore, we can find the friction angle, which works out to be 18.26 degrees. So the angle of inclination that will require the least force equals the friction angle. Therefore, the angle of inclination that will require the least force is 18.26 degrees. The second relationship involving the friction angle we're going to investigate is that between the friction angle and an object sitting on an inclined plane. Consider the object to the right sitting on an inclined plane. The weight of the object W acts towards the center of the Earth. The weight can be broken into components that act perpendicular to the plane, Wx, and parallel to the plane, Wy. The component of the weight that acts parallel to the plane, Wy, acts to slide the object down the plane due to gravity. Friction force opposes the component of the weight that acts to slide the object down the plane. So the friction force Ff will equal the component of the weight that wants to slide the object down the plane, Wy. If we increase the angle of the incline, we increase the portion of the weight that acts to slide the object down the plane. Eventually, the angle will be great enough that the component of the weight acting down the plane will equal the maximum static friction force. At this point, the object is ready to slide down the plane without a force being applied. The angle of the incline where the object is ready to slide with no force applied has the same value as the friction angle. So if we know or can find the friction angle, we know the angle of the incline where the object is ready to slide down the incline due to its weight. Example 5. An object has a mass of 100 kilograms. The coefficient of static friction between the object and an inclined plane is 0.35. At what angle of incline is the object ready to slide down the plane with no applied force? Example 5. An object has a mass of 100 kilograms. The coefficient of static friction between the object and an inclined plane is 0.35. At what angle of incline is the object ready to slide down the plane with no applied force? Observation. The angle of the plane that will cause the object to slide with no applied force has the same value as the friction angle. Step 1. Find the friction angle. The tangent of the friction angle equals the coefficient of friction. So therefore, the tangent of the friction angle will equal 0.35. The friction angle, therefore, equals 19.3 degrees. Step 2. Find the angle of the plane that will cause the object to slide with no applied force. The angle of the plane that will cause the object to just start sliding without an applied force equals the friction angle. Therefore, the angle of the plane that will cause the object to slide without an applied force equals 19.3 degrees.